Hello, this video is a review of basic absolute value equations and solving inequalities with variables on both sides. So we have two learning targets that go with this. The first one says, I can solve absolute value equations. And the second one is, I can solve inequalities with variables on both sides. Again, this is something that should be reviewed for most of you, and it's a good idea to watch it before we move into some new stuff or more complicated things so you feel comfortable with this. So if you have questions, please ask, and I am happy to help. So when we're solving absolute value equations, recall that absolute value measures a number's distance from zero. So if you have the absolute value of x equal to a positive number, then there are two solutions, and there's an error here. It should be absolute value of x is equal to 17, like that. And then your solutions would be x could be positive 17 or negative 17. If the absolute value of x is equal to 0, then there is only one solution. And if the absolute value of x is equal to a negative number, then there are no solutions. And if we think about absolute value measuring distance from 0, we can't have a negative distance. So it makes sense that if the absolute value is equal to a negative number, then we don't have any solutions. All right, we're just going to jump right into some practice. So the key thing to remember is that we want the absolute value bars to be by themselves on the side of the equation. So what I mean is, if we look at this side, right here, the left side, we don't want anything outside of the absolute value bar. So we don't want anything on the left of it or the right of it, which there's not. The +4 on the inside is okay. So from here, what we need to do is we're actually going to split this into two equations. And I'll explain why. So the first one is going to stay x plus 4, so I drop the absolute value bars, is equal to 8. Because that's the positive solution. The second one will be x plus 4 is equal to negative 8. That's our negative solution. And now I solve each of them independently. So here I would subtract 4, and I get x is equal to 4. That's one solution. Subtract 4 here, and that's my second solution. So both of these are solutions to that absolute value equation. So now let's look at our example on the right. So the left side of the equation, the x plus 9 and absolute value bars, is not by itself yet because of this plus 5 out here. So I'm not going to write my two equations until I move that plus 5. So I have to subtract 5 from both. Now I have absolute value of x plus 9 is equal to negative 3. So now there's nothing outside of the absolute value bars. So there's nothing on the left side or the right side. So I'm good to go from here. But now if I stop, I have the absolute value of x plus 9 is equal to negative 3. So it's equal to a negative number. That's not possible. I can't have a negative distance, so there are no solutions. Okay, one more example. In the absolute value bars, I have x minus 3, but there's something outside of them on the left side that I need to move. It's that plus 6. So I'm going to subtract that. Okay, absolute value of x minus 3 is equal to 0. Now if you think about the slide a couple back, I said if you get it equal to 0, there is only one solution. So here in my head, I'm kind of reminding myself there's only one solution. So I can only rewrite this as one equation. X minus 3 is equal to 0. I can't write a second equation because there's no such thing as having a negative 0. So then I just have to solve this one and get x is equal to 3. Okay, on to inequalities. Solving inequalities is almost exactly like solving equations. You will keep the sign the same unless you're multiplying or dividing by a negative number, and then you flip the sign. Remember, when I say sign, I'm talking about less than or equal to, greater than or equal to. So we're going to look at two examples. So let's do the one on the left. It says x is less than 3x plus 8. So I need to combine like terms. I'm going to combine the x's. So since it's a positive 3x, I'm going to subtract it. So So I'm left with negative 2x is less than 8, and then I'm going to divide by negative 2. So here, because I'm dividing by a negative, I need to flip my sign. So it becomes x is greater than negative 4. So notice my sign is different than my original less than because I had to flip it. For the one on the right, I see parentheses, so I'm going to distribute right away. So I get 6 minus 6x is less than 3x. Need to combine like terms, so I'm going to add 6x to both sides. And I get 6 is less than 9x, and I need to divide by 9. So I get 6/9 is less than x. Let's simplify our fraction. I can divide both of those by 3, so I get 2/3 is less than x. If you prefer x on the other side, so written on the left side, then when I flip x to the other side, I also need to flip the symbol. So these two actually say the same thing, just in different ways. Okay, so we have some special cases called all real numbers and no solutions. And it says if the inequality is true after solving, then there are infinite solutions, or solutions are all real numbers. And if the inequality is not true after solving, then there are no solutions. So these typically show up when the variable drops out of your inequalities. So for example, you go to combine terms and they add up to 0. This will make more sense when we look at our next two examples. So let's do the left one. It says x plus 5 is greater than x plus 3. So here I'm going to start by combining my numbers. So I'm going to subtract 5. So remember, I'm still starting it the same way. So I have x is greater than x minus 2. Subtract x. So here's where my variable goes away, because x minus x is 0. So I'm left with 0 is greater than negative 2. So there's no variable left here. So now is where I ask myself, is that statement true or false? So is 0 greater than negative 2? That's true. It is greater than negative 2. So that's infinite solutions. Or if you like to say all real numbers, you can. And let's look at the one on the right. I do need to distribute. So I get 2x plus 6 less than 5 plus 2x. From there, I can subtract 6 from both sides. So I'm left with 2x is less than negative 1 plus 2x. Subtract 2x. Again, now my x's are gone. I'm left with 0 is less than negative 1, so it's a special case. There's no variable left. So I ask myself, is 0 less than negative 1? That's false. So there are no solutions. I'm going to say no solve or no solutions there. So those are an example of each of our special cases. Thanks for watching. Again, if you have any questions, please feel free to ask. I did not mention graphing inequalities in this video, so please watch the other YouTube video I posted, or feel free to search for your own video or ask for help during class if you have questions.